Alright folks, so this video might be a little bit long because I'm going to go through a whole problem how to solve a two-dimensional problem. But first thing I need to do is show you the problem. A ball is rolling at 5 meters per second. When it rolls off a table that's 1 meter high, how far from the base, and here's the base, right, of the table, how far from here, how far from here, what was that? There we go. So it's asking how far, like this distance, how far is it going to land? And so we know that when it flies off the table, I think you guys know it's going to fly off and it's going to fall somewhere, right? So it's going to fall somewhere. And they want to know how far from the table will it land. It's actually, this is a two-step process. It's not crazy, but you have to imagine this, that when this ball is falling, so it's kind of rolling, let's say like right here, um, at this point right here, and actually any of the points right here, so anywhere here, it doesn't matter which one. It is falling, so it's a free fall. It's free falling, and gravity's acceleration downward in the up and down direction is negative 9.8. That's the normal stuff that we already know. And in the up and down, the y-axis, and so I'm going to give you a hint here. We're going to break everything down to x and y, okay? So x is left and right, so this way, and y this way. And we have to do it that way. So if we look at the y, the initial velocity is 0 meters per second. Now, this speed right here is purely to the right. It's going all to the right. And there is no up and down speed at all. So the second it leaves the table and it falls off, like right here somewhere, and it starts to fall off, its y speed is nothing. Then it starts to go faster and faster. I'm putting longer arrows for faster speeds, and faster downward. But the whole time the ball is staying at 5 meters per second to the right. Even right here, it's still going 5 meters per second to the right. So what we got to do is look at both separately. So this is a two-step process. Step one, you have to find out how long will it take to fall. So step one is we have to figure out how long is it going to take to hit the ground. So we're going to get a time. And step two, let me scroll this down a bit. Step two is a simple v equals x over t. So we solve for x and you just get this. Because in the left, there's no acceleration left and right. The only acceleration is up and down, gravity pulling up and down. So when we do this one, we're going to calculate gravity and just pretend like the object fell and figure out how much time it took. Once we know that time, so we're going to get a time here, right? So we will get a time here. We're going to plug that in here. This, for this problem, the velocity, is 5 meters per second. It always is 5 meters per second. The time, I don't know how long it's going to take to fall until I do a calculation. So let's do that calculation here. So in the y position, that's how we calculate time. We're going to first look at the y position. Was it thrown down or anything like that? Did it have any up or down speed? No, this rolled right off the edge of a table. So the y speed is 0. What else do we know? Oh, I know that the change in x is from here, and we know this distance here is 1 meter. So its change in x will be negative 1 meter because it went down. It moved down from where it started. So negative 1 meter. We know a is negative 9.8 meters per second squared. And I think, what are we looking for? Time? Okay, so time. And I think we should be able to solve that now. The only equation I think that will work is I think we have this one. Delta x equals initial velocity times time plus 1/2 at squared. This right here is 0, so that works out. And so we're going to get delta x is equal to 1/2 at squared. And we know all these things perfect. So negative 9.8 for the a. T is a squared. I don't know what it is. 1/2. We'll multiply those. Is equal to delta x. Oh wait, no, we don't. We know delta x, don't we? So let's go back and fix that. Delta x is negative 1 meter. Okay, so we know that it's from negative 1 meter, and this is going to be negative 4.9 t squared is equal to -1. Let's divide by -4.9. Divide by -4.9. This is looking good. Negative divided by negative. I'm saying it's looking good because the reason I'm saying it looks good is that we're going to get a positive time, which is good because I told you if you have negative time, you probably did something wrong. So let's do a calculator real quick here. And I got 1 divided by 4.9. I didn't put the negatives in because I already know a negative divided by a negative is a positive, so I'll just leave them all positive. 0.20, not very, that's pretty fast. 0.2, oh, that's not the time yet, that's why. I was going to say 0.204, so we get 0.204, but that's not the time yet. That's the time squared. So let's square root that. Let's square root that side. And now finally, we know how much time it's going to take to hit the floor. Let's square root that number right here. There we go, 0.45. So 0.45 seconds, that's how long it will take to hit the floor. Did we care how fast it's moving to the right or left? No, we do not. I don't care how fast it's moving to the right or left. Gravity doesn't care. Gravity does not care if you, and if you guys can see my little video here, gravity does not care if you're going really fast this way, because gravity will pull you down the same. It does not go, well, you're moving really fast to the right, so I won't pull you down as hard. It doesn't think like that. It just pulls you down, whether you just let it go and it falls, or if it shoots off to the left. I will provide a video for that, like a little warm-up video, and you might have already seen it already, that that shows and demonstrates that, like in an experiment. So now that we know the time, this is a quick, in the X, by the way, doesn't matter which problem you do in two-dimensional physics. So anytime you have projectile motions, these are called projectile problems or two-dimensional problems. In the X, left and right, you can only use this equation. This is the only equation you can use because there's no acceleration. So it's quite simple. So if we plug everything in, I know that in the X direction it's moving 5 meters per second to the right. I want to know how far it's going to go this way, right? The left and right distance. And how long is it going to do that for? 0.45 seconds. I know that because I did calculations in the Y to figure that out. So let's times 0.45 on both sides. Times it here, times 0.45 over here. And these cancel out over here. And I will times that by 5. Clear 0.45 times 5 is 2.25. And that's our final answer. Delta X is equal to 2.25 meters. And that's it. So as a recap, if you're looking at the left and right direction, you're only going to use this equation only. Okay? On the Y direction, you have to use one of our gravity acceleration problems to figure out how much time will gravity take to make it. How much time will this thing have in the air? So the left and right, that speed's just going and going and going. It'll go forever until gravity smacks it onto the ground and says, nope, you're not going any further. So I need to do a calculation to figure out how much time is this thing going to be in the air. Then I can apply that and say, hey, your speed here, this speed here, you can go that speed 5 meters every second to the right for this amount of time. And that's it, because gravity is going to smack you onto the ground and you can't go any further after that. Will the ball roll after that? Maybe, maybe not. I don't know what the ground's made out of. It might be made out of Play-Doh for all I know. It doesn't really matter. We're just talking about how far it can go before it whacks the ground. And that's the answer, guys. So try some practice problems out using this exact method, and make sure you take these notes and write them down so you know the method. Remember, calculating the time, then using that time in a simple velocity problem, and then you can figure out how far it goes, and that's it.